Okay, we're going to be looking at pages 11 and 12 from the packet. We're going to be looking at how to factor a trinomial when the leading coefficient is not 1. So the problems you did last week, all of the trinomials had a leading coefficient, or in other words, then there was no number in front. The leading coefficient was 1. Now you're going to be having a number in the first term when it's in descending order, okay? So when we do that, I want to get out of the way, you always check for a greatest common factor. So if we look at this first example, they don't have anything in common, so we're good. There's no common factor. Now we're going to multiply the first and the last coefficient together, okay? Or the first number, that's a 5, and the last number is a 6. We're going to multiply those together and get 30. Okay, simple. Step 2, list the factor pairs of that product. Okay, the product was 30, so I'm going to list the factor pairs for 30. That'll be 1 and 30, 2 and 15, 3 will go into 30 10 times, 4 won't go into 30, 5 will go into 30 6 times, and then we're circling back around because 6 will go into 30 5 times. All right. Step 3, determine which factor pair combines to equal the middle number of the problem. Okay, so the middle number of the problem is a 13. Which factor pair combines to give me 13? This is the factor pair that does. Okay, now in this problem, it's pretty simple because the signs are going to be the same. They'll both be positive. But I do want to point out, whenever the signs are different, in this step, you want to use, this is where you will also use the sign rules that we learned last time. So in other words, when we get to here and we look at these factor pairs, I can say, okay, their signs are going to be the same and they're both going to be positive. The larger one is going to be positive and the smaller number is going to be positive. Okay, you can see where that would be helpful whenever the larger number is negative and the smaller is positive. Then whenever you just write the signs in, it'll be easier to see which ones will combine to give you 13. All right, so we determined the factor pair that combines to give me the middle number. Now, what we're going to do is we're going to rewrite the middle term of the problem. Okay, so we're going to rewrite the problem. The first term is going to be the same, 5x squared. The second term, or the middle term, the 13x, I'm going to rewrite it using these numbers. Okay, so instead of writing 13x, I'm going to put a 3x plus 10x. Okay, and then the last term will stay the same. Okay, so that is the new, what's really new is rewriting the middle term of the problem. So instead of taking 13x, I'm going to write it as 3x plus 10x. Because what is 3x plus 10x? It's 13x. So I haven't changed the value of anything, I've just rewritten it. Okay, now we are going to solve. If you look, we have 4 terms now. Those 4 terms, when we have a 4-term polynomial, we are going to solve by grouping. And grouping was on pages 5 and 6 of the packet. So I've thrown in a couple of grouping problems in the homework as we've been working it. But if you don't remember, look back at that, okay? So whenever you have a leading coefficient other than 1, you're going to be rewriting the middle term, and then you'll have a 4-term polynomial that you solve by grouping. Okay, so whenever you remember solving by grouping, you group the first 2 terms together and you group the last two terms together. And then we look for a common factor. So let me write the prime factors of this would be 5 times x. The prime factors of 3x are 3 times x. Okay, the only thing they have in common is an x, so I'm going to factor out an x, and I'll be left with a 5x plus 3. Now we go to the second group, and I look at the prime factors. 10 is the same thing as 2 times 5 times x. 6 is the same thing as 2 times 3. They both have a 2, so I'm going to factor out a positive 2. And whenever you do, remember, these binomials should end up looking the same. So right now, you should be checking to make sure. Okay, they do look the same. So this first group has a 5x plus 3, and the second group has a 5x plus 3. So I factor out the 5x plus 3, and what I'm left with here is an x, and here I'm left with a plus 2. So that's my answer. Okay. Now, what would happen if when we rewrote the middle term, I wrote these in a different order? I'm going to go ahead and work that. You don't have to copy this down, but you can watch me work it. Okay, so whenever I rewrite the middle term, I'm going to write the 10x first, and then the 3x. Okay, now it's a 4-term polynomial, so I'm going to factor it by grouping the first two together. Now they have a 5x in common, so I'll take that out. I'll be left with an x plus 2. Wait, I'm taking out that one, and I'll be left with x plus 2. These two have a 3 in common, so I'm taking out a positive 3, and I'll be left with an x plus 2. So now when I look at my two groups, the binomial they have in common is an x plus 2. So I factor out the binomial x plus 2, and I'm left with a 5x and a 3. Okay, so you'll still get the same answer. It'll just look a little different whenever you do your factoring by grouping. Okay, so from now on, I'm not going to work these problems both ways, but be aware when you do your homework, you may write these two middle terms in a different order, but you should still get the same answer. You'll be going about it in a different way because the binomial that they have in common will be different. Okay, so now let's do the second example. So we are going to multiply the first and the last together, and that gives me a 300. Now we have to list the factor pairs of that product. So the factor pairs of 300. Okay, 1 and 300, 2 and 150, 3 and 100. 4 won't go into it, 5 will go into it, 60, 6 will go into it, 50, 7 won't go into it, 8 won't, 9 won't, 10, and 30, and 11 won't, 12, no, 13, no, 14, 15, and 20. Okay, that's all of them. All right. Now you have to determine which factor pair combines to equal the middle number. And I'm going to use the sign rules to help me do that. So let me check the signs. They are going to be the same, and they are both going to be negative. So I know the larger factors are going to be negative, and the smaller factors are going to be negative. So now I can look at this and decide which factor pair will combine to give me a negative 35. All right, which one will that be? Right here. This factor pair combines to give me a negative 35. So now I'm going to rewrite the middle term of the problem using this factor pair. Okay, so the first term is going to stay the same. oops, 10x squared. The middle term, which was a negative 35x, I'm not changing its value, I'm just rewriting it as a negative 15x and a negative 20x. Okay, and then the last term is going to stay the same. All right, once you rewrite the middle term, then you have a 4-term polynomial, and we are going to factor the 4-term polynomial by grouping. So we'll group the first two together and the last two together. When you group the first two together, we have to factor out the common factor. So let me write the prime factors. This is 2 times 5 times x. There's a minus sign, so it's a negative 1 times 3 times 5 times x. Okay, what do they both have in common? They both have a 5, oops, and they both have an x. So I'm going to factor out a 5x. What's left in the first term is a 2x, and then what's left in the second one is a minus 3. Okay, so whenever I go to do this one, I'm going to need a 2x minus 3 that's going to be left. So I'll keep that in mind. All right, so let me list the prime factors of this one. There's a minus sign, so I'm going to put a negative 1, 2 times 10, and 10 is the same thing as 2 times 5. And then we have the x. 30 is 3 times 10, and 10 is the same thing as 2 times 5. All right, what do they have in common? They both have a 2, and they both have a 5. And 2 times 5 is 10. So I'm going to be factoring out a 10. And then what's left? It would be a negative 2x plus 3. But I need the signs to be opposite. So what you're going to be doing is you're going to be factoring out a negative also. Well, how can you factor out a negative if there's not a negative over here? Well, there actually is, because what is negative 1 times negative 1? It's a positive 1. So anytime you need to factor out a negative, just know that it's there. Okay, and whenever you do factor out the negative, you'll be left with a negative. Okay, so in other words, when you factor out a negative, the signs are going to change. It was a negative, now it's going to be a positive 2x, and this was a positive 3, now it's going to be a negative 3. So if you need the signs to be different, put a negative out here, and then you can change the signs. Okay, now when we look at it, we look for the binomials to be the same, and they are. So we have a greatest common factor that is a binomial. I'm going to factor out the binomial. Oh, minus. Okay. Factor out the binomial. And whenever I do, in the first group, I'm left with just a 5x. In the second group, I'm left with a minus 10. Doggone it. You know what? I'm looking at this. I had a greatest common factor. Okay, so now you're seeing this in the video, and when I worked this, I had, let me write this down, 1341. Okay, now when you're looking at the video, you see I've already worked this whole problem, but the deal is I didn't check for a greatest common factor. So I'm going to leave this here, but you don't have to put this in your notes, okay? I'm going to rewrite the problem over here. 10x squared minus 35x plus 30. Okay, there is a greatest common factor. They all can be, they all have a common factor of 5. Okay, so I'm going to factor out a 5, and you can do the greatest common factor steps to do that. I'll be left with a 2x squared minus 7x plus 6. So now this is the trinomial I'll be factoring. And that greatest common factor, I'll just put it in purple so you can see. It'll be out to the side. It'll be written with our answer. Okay, so what I'm going to do now is multiply the first and the last number together and get a 12. You can see before I had a huge number. That's no fun working that. But 12, it's much easier to work with. Okay, the factor pairs of 12 are 1 and 12, 2 and 6, 3 and 4. Now remember, I'm going to use the sign rules to help me pick the correct factor pair. So I have to determine which factor pair combines to equal the middle number. Well, the middle number is a negative 35, but before I do that, I want to look at the signs. This is, oh, it's not a negative 35. Okay, I'm going to use the signs to help me figure out which factor pair will combine to give me the middle number. So before I decide that, let me check the signs. This is telling me the signs are going to be the same and that they are both going to be negative. So I know the larger factor will be negative and the smaller factor will be negative. So I'm going to go ahead and write the signs there. It'll make it a little easier to see. Okay. Which factor pair combines to give me the middle number? Well, the middle number is a negative 7. So which factor pair would combine to give me a negative 7? A negative 3 plus a negative 4 is a negative 7. So I'm going to use this information to rewrite the middle term. Okay, so the first term is going to stay the same. It's going to be 2x squared. The middle term will now be written as a minus 3x and a minus 4x. And then the last term is a plus 6. Okay, now I have 4 terms. I can factor 4 terms by grouping. So I'm going to group the first 2 together and the last 2 together. The first 2, well, those are prime numbers, so this is going to be easy to take out the greatest common factor. Here's a negative 1 times 3 times x. Now they both have an x in common, so I'm going to factor out an x. I'll be left with a 2x minus 3. Over here, we have a negative 1. 4 is the same thing as 2 times 2, and then an x. 6 is the same thing as 2 times 3. So they both have a 2 in common, so I'll factor out the 2. Whenever I do, I'm going to be left with a negative 2x plus 3. I need it to be 2x minus 3. So I'm going to have to factor out the negative also. But this one doesn't have a negative. Well, it actually does, because a negative 1 times negative 1 is a positive 1. So we can always manipulate things and write extra things that don't change the value. So you can factor out a negative 1. Now you'll be left with a 2x, and then 3 times negative 1 is a minus 3, okay? Or you can just look at this. When you need these signs to be different, factor out a negative, and then it'll change the signs inside. This one will be positive, this one will be negative. All right, now we look at it, and you can see they both have a binomial. So they have a greatest common factor that is a binomial. I'm going to factor out the binomial from the first group, and I'll be left with an x. Factor out the binomial from the second group, and I'll be left with a minus 2. And then don't forget, we had a greatest common factor of 5. This is the correct answer. Now let's talk about this for a second. When I worked this without checking for a greatest common factor, I got an answer, and you see here, this binomial has a greatest common factor in it. The greatest common factor would be 5. When I wrote this answer, as soon as I wrote this, I saw that they had a factor in common, and I was like, dang it, that means I forgot to take out the greatest common factor. So when you get to this point and you recognize that your 2 numbers could be factored, or you could take out a greatest common factor, then you know you should have done it at the very beginning. But if you don't have to go back and rework it, you can just say, okay, they both have this is 5 times x, and this is a 2 times 5. They both have a 5 in common, so you can just take the 5 out, and then you have your 2x minus 3, and when you take the 5 out of this one, you'll be left with an x minus 2. Okay, so you can still, if you realize that you worked it and didn't take out the greatest common factor, when you get your final answer, you can still take the common factor out of one of the binomials. All right. Example 3. I'm going to go ahead and zoom in for this one. Okay, so step 1 said multiply the first and last number together. So we're going to do that and we get a 10. Step 2 is to list the factor pairs of that product. So the factor pairs of 10 are 1 and 10 and 2 and 5. Okay, step 3 is to determine which factor pair combines to give me the middle number of 3. But I also want to use the sign rules that we learned. Remember, if this is a minus, then that tells you the signs are going to be different. This one tells you the larger one will be positive. So I can go ahead and look at these factor pairs and say, okay, the larger of the pair is going to be positive, and the smaller will be negative because the signs have to be different. Whichever factor pair it's going to be, it doesn't matter, but it has to be that way. So we'll go ahead and put the signs there now. It just makes it easier to see. Now when we go and pick which factor pair will combine to give me the middle coefficient, you can see that it is a -2 plus 5 that gives you 3. So we're going to use that information to rewrite the middle term. So the first term will be 2y squared. The middle term, 3y, we're going to rewrite that using a -2y plus 5y. Because what is -2y plus 5y? It's 3y. So we haven't changed the value, we just rewrote it in a different way. Now when you do this, you end up with a 4-term polynomial. When you have a 4-term polynomial, you can solve it by grouping. So we're going to group the first 2 together and the last 2 together. The first 2, this will be a 2 times y. There is a -1 times 2 times y. So I can see that they both have a 2 and they both have a y. So I'll factor out a 2y from the first group and I'll be left with a y minus 1. Okay, the second group, the prime factors would be 5 and y, and the prime factors here would be a -1 and a 5. So they both have a 5 in common, so I'll factor out a +5, and I'm left with a y minus 1. So now when I look at these, I can see the first group has a binomial of y minus 1. The second group has a binomial of y minus 1. So that binomial is a greatest common factor. I can factor out the y minus 1, or in other words, take out the y minus 1 from the first group. And whenever I do take it out of the first group, I'm left with a 2y. When I take it out of the second group, I'm left with a +5. Okay, so if, let's say you're doing your homework and you had worked this and you switched the order of these two when you're doing your homework, then when you get your answer, the binomial that they have in common will be the 2y plus 5. Okay, so you're going to have the same answer, it's just these would be in a different order. And so it doesn't matter what order your binomials are written in for your final answer. All right. Now you try example number 4. If you pause it and try example number 4. Okay, so The first step is to multiply the first and, oh, first of all, check for greatest common factor. There isn't one. So we multiply the first and the last number together. 4 times 7. Sorry, I'm switching my notes. Okay, 4 times 7 is 28. All right, step 2 is to list the factor pairs of that product. So the factor pairs of 28 are 1 and 28. 2 will go into that 14, 3 won't, 4 will go into that 7, 5 won't, 6. Okay, so that's it. Now I'm going to use the signs to help me pick the factor pair that equals this. So this is telling me that the signs are going to be the same and both of the factors will be negative. So the larger factors will be negative, the smaller factors will be negative. Now I can look and determine which factor pair combines to give me a -1. Okay, does any factor pair, a -1 and a -28 is a -29. A -2 and a -14 is a -16. A -4 and a -7 is a -11. So none of these equal a -1. So guess what your answer is? Your answer will be prime. Now, if you paused the video and tried this one, you probably got to here and were like, what do I do? Or you might have thought, I bet it's prime. Okay, so I'm gonna highlight this just to make sure that y'all pay attention to that. Sometimes it will not factor, so your answer will be prime, or you can just write the original problem. Either one is a correct answer. Okay, example number 5. Go ahead and pause it and try working that example on your own. All right, so step 1 is to multiply the first and the last number to get, oh wait, check for greatest common factor, there isn't one. Okay, multiplying the first and the last number together, I'll get 2. Step 2 is to list the factor pairs of that product. So that's only one set of factor pairs, okay? Now the third step is to determine the factor pair that equals the middle number. Before I do, I want to check my signs. This is telling me the signs are going to be different. This is telling me that the larger number will be negative, so this one's going to be negative, this one's going to be positive. Now I need the factor pair that will rewrite equal a -1. Okay, +1 minus 2 gives me a -1. So I'm going to use this to rewrite the middle term. Okay, so I will have 2n squared, first term stays the same. When I rewrite the middle term, I'll write it as 1n minus 2n, and then the last term will be the same. Okay, after you rewrite the middle term, then you have a 4-term polynomial. When you have 4 terms, you can factor by grouping. So we're going to group the first 2 together and the last 2 together. I look at the prime factors to be able to pick out the greatest common factor, and I can see the only thing they have in common is an n. So I'm going to factor out an n, and I'll be left with a 2n plus 1. Okay, the second group, I'm going to look at the prime factors so that I can see what they have in common, and all they have is a -1. So I'm going to factor out a -1, and I'll be left with a 2n, but there's nothing here. Remember, there's always an understood 1, and you have to have that placeholder there. Okay, now when we look at our groups, you'll see the first group has a binomial of 2n plus 1. The second group has a binomial of 2n plus 1, so they have those in common. I can factor out the binomial, since it's a common factor, from both groups. When I factor out from the first group, I'm left with an n, When I factor it out from the second group, I'm left with a -1. So that's the answer. Now, if you worked this and you wrote these in a different order, then when you get to this step, the binomial that they have in common would be the n-1. And what's left would be the 2n plus 1. Okay, so depending on which way you rewrite the middle term, you'll still get the same answer. It's just these would be in a different order. All right, good job.